This is review module 19 circles. Number 1. On number 1, you take the 360, which is a whole circle, subtract 116 and 140, you end up with 104. That'll be this arc here. And if you divide that in half, you'll get the inscribed angle for x, which is 52. On number 2, we have a rule. So 5 times x is equal to 4 times 10, which 4 times 10 is 40. If you divide by 5, you get x equals 8. On number 3, we're looking for this pink angle here, which is angle AOF. In order to find it, we're going to need to add the opposite arcs, which is 105 plus 55, divide that by 2, and we get 80. On number 4, this was a mistake. We used to have the x here and the 10 here. I actually switched it to 3 and x so that we can practice what we need to for a test. So it's 3 times 3 plus x, which is here, and then 5 times 5 plus 7, which is here. And this entire side, the way I do it is 5 plus 7 is 12. 12 times 5 is 60. 3 times 3 is 9, and 3 times x is 3x. Move the 9 to the other side, over here, it becomes a negative. 60 minus 9 is 51. If you divide by 3 on both sides, x is equal to 17. Number 5. In order to find this arc, we need to take the entire circle, which is 360, take away 100, another 100, and a 50, which that'll leave us 110, which is the arc we were needing. So now we can do 110 minus 50 divided by 2 equals the outside angle, the exterior angle, which is x. That gives us x equals 30. Number 6. This is a tangent and a secant. X times x equals 2 times 2 plus 6. 2 plus 6 is 8. 8 times 2 is 16. X squared equals 16. If I square root both sides, x is equal to 4. On number 7, 200 minus x divided by 2 equals 50, which is the outside angle. If I multiply 2 times 50, I'm going to get 100. I'm going to have 200 minus x equals 100. I'm going to switch both of these here. If the x moves to the right side, it becomes positive. But if the 100 moves to this side, it becomes negative. 200 minus 100 is 100. So x equals 100. These are both tangents. That means they're equal to each other. So 7x minus 2 equals 3x plus 8. Solve the equation, and we end up with a fraction, 10 over 4. If you divide both of them by 2, you end up with 5 over 2. The problem is actually asking me to find the length of AD, which is this one. So AD is 3x plus 8. So I'm going in the place of the x, I'm going to substitute 5 over 2. You can see me do that right here. Now the 3 is on top, so is the 5. So 3 times 5 is 15, and it's all divided by 2, which I get 15 divided by 2. Plus 8, and 8 is over 1. Now the denominators are not the same. So in order for me to turn the denominators equal to each other, I need to multiply this one by 2. But what I do to the bottom, I must do to the top. So I end up with 16 divided by 2. And then I'm adding that to the 15 over 2, which turns into 31. And since the denominators are the same, they stay the same. You don't add these two together. And AD is 31 over 2. You could turn that into a decimal if you'd like. On number 9, these two angles add up to be 180. So x plus 64 equals 180. If I subtract the 64, x equals 116. This concludes page 1. On number 10, this green angle is actually a right angle. The reason I know that is because this line is a tangent and this segment here is a diameter. That means that when they cross, they form a right angle. That means that if I know this angle is 20, Together they make 90, which would make this one 70. I did that here where I knew this one was 20, this one was 90. Subtract the 20. That means the angle that I had here is 70. But the problem's asking me for the measurement of arc BC, which BC starts here and goes there. That means that I need to find that by multiplying my 70 times 2. So that means I'm taking my angle, I'm multiplying it by 2. 70 times 2 is 140. On number 11, opposite angles add up to be 180. So y plus 73 equals 180. That means y equals 107. 2x plus 106 is equal to 180. 2x is equal to 74 because I'm subtracting the 106. And then I'm dividing by 2, so x equals 37. On number 12, this angle here is 90 degrees. I know that again because this is tangent and that is the radius. When I have a tangent and the radius, they form a right angle, which means that now I have a right triangle. I'm going to pull that right triangle off to the side. I know this is 16, that's 12. And the whole thing here, the whole piece here is x. And I know this is 12 because this is a radius and this is also a radius. But for now, I just want to find this whole thing. So that means x squared equals 16 squared plus 12 squared. The hypotenuse always goes first. You find the hypotenuse across from the 90. X squared goes first. 256 plus 144 is 400. If I square root both sides, x is equal to 20. The problem is asking me for the length of FD. That means I need to find only this piece, which was not given to me. But now I know x. X is 20. And I knew this was 12. So that means that if I'm looking for FD, FD plus FB equals DB. FD I don't know. FB is 12. DB is 20. If I subtract 12, FD is 8. On number 13, this angle has the arc PQ. This angle, PRQ, has also the arc PQ, which makes these two angles equal to each other. So I can set them equal to each other, solve for y. Y is equal to 20. And then now I can find the measurement of angle PRQ. PRQ, which is 2y plus 15. And I know y is 20. So 2 times 20 is 40. 40 plus 15 is 55. I'm also looking for the measurement of the arc PQ, which is here, which is our x. Well, since I found this angle to be 55, if I multiply it by 2 here, 55, multiply by 2 will give me the arc PQ. So 55 times 2 is 110. And I knew that I needed to find those because the problem started me off with wanting to find the measurement of arc PQ. That was the goal. Number 14. This is a central angle. QOP is a central angle. That measurement is 80. The arc that intercepts that is actually equal, so that is also 80. Now, angle QRP is an inscribed angle, which means it's not a central, which means these two are not equal to each other. But now that I know 80, I can divide it by 2, and if I divide that by 2, I get 40, which is the angle I was missing. So for the arc QP here, it's 80, and for the angle QRP, it's 40, because I took the arc and divided it by 2. Number 15, I need to solve for x. X is here. Now, since this is a diameter, because they told me here that the diameter is PR, this is a diameter, and whenever I have a chord crossing a diameter, they're actually forming a right angle. So now I also know that it's a perpendicular bisector at the same time, actually. So and it's telling me here that it's a perpendicular bisector of the chord. So if it's a perpendicular bisector, not only is it forming the right angle, but it's cutting my segment in half into 2 equal pieces. They already told me this one's 5 from A to Q. That means the other side is Q to B is also 5. And they also told me that P to Q is 3. So now I can do 3 times X equals 5 times 5. Or you can start with 5 times 5 equals 3 times X, which is what I did. So 25 equals 3X. If I divide by 3, X equals 8.3 because it was not even. On number 16, this is a secant and a secant. So 5 times 5 plus 4.5. 5 times 5 plus 4.5 equals 5 times 5 plus X. 5 plus X. 5 plus 4.5, 9.5 times 5 is 47.5. Here I cannot add the 5 and the X, so I need to distribute. So 5 times 5 is 25. 5 times X is 5X. Subtract the 25. 22.5 equals 5X. Divide by 5 on both sides. X equals 4.5. That was the first part of it. The second part is that they're asking me for BD. BD is 4.5 plus 5, which is 9.5. FD is X plus 5, which I now know X is 4.5 plus 5, which is also 9.5. This concludes page 2. Number 17. This is a secant and a tangent. Tangent, 1 times 1 is equal to 0.5 times 0.5 plus X. Here 1 times 1 is 1. 0.5 times 0.5 is 0.25. 0.5 times X is 0.5. Subtract the 0.25. 1 take away 0.25 is 0.75. Divided by 0.5, X is equal to 1.5. That's the first part of it. The second part is that they want me to find I all the way to K. Now that's 0.5 plus my X, which is now 1.5. So 0.5 plus 1.5 is 2. On number 18, I'm trying to find this pink angle. I have two arcs across from them. If I add them together and then divide them by 2, I get my answer for the pink angle, which is 81. Alright, on number 19, I'm looking for angle ABE, which is this pink angle. Now I'm going to find that pink angle by taking the arc, which is BE, which is 128, and dividing that by 2. I get 64. For the arc CE, which is this green arc here, I'm going to find that arc by taking my angle, which is CED, and multiplying that by 2, and I get 136. On number 21, I'm going to do that right now. On number 21, we have an entire circle, which is 360. We need to take off 180 and 148. And we also need to take off this little piece here, which is X, which is, if we're taking things off, we're subtracting. And that'll leave us with this one piece here. So we're going to start here. 32 minus X. Take away that little piece X here. We're going to divide that whole thing by 2. And it's going to equal to the angle, which is over here, which is 12. So this is a theorem that you learned in class. Make sure you go look it up. If we multiply by 2, we're going to get 24. So now I have 32. And negative x turns into negative 2x. So now we have 32 minus 2x equals 24. If I switch this one to the other side and I switch 24 to this side, I'm going to have 32 minus 24 equals to 2x. That this turns into 8. 8 equals 2x. We divide by 2 on both sides. X equals 4. That's my answer. X equals 4. Number 20. They're asking us to find this pink angle here, which is, I found it to be 119. The way I found it was by adding the 188 plus this orange arc here, which is 50. So this entire thing is my where my angle starts and ends. So I'm going to add them together and divide by 2 and I get 119. That's how I found 119. For arc IJ, IJ is this piece here. Now, I'm going to use the angle that's in yellow, which they told me was 46. But that angle, if I were to multiply that number by 2, it gives me the green arc and the orange arc put together. So my green arc plus my orange arc equals my yellow angle if I multiply by 2. So I know my yellow angle is 46. If I multiply by 2, I get 92. And I also know the orange arc, which is 50. So now I have the green arc, which I'm missing, this one here, plus 50 equals 92. If I subtract 50, that means my green arc is 42. And that's what I got as an answer. Number 22. Now I have an entire circle, which is 360. I'm choosing this to be my variable, my arc piece that I don't know. It starts at D, wherever this line touches the circle, and it ends at E, wherever this ray touches the circle. Now since that's X and the whole circle's 360, I could take my 360 and take off this X piece. And if I take off the X piece, that'll leave me the rest of the circle, which starts at D, goes around through P, and comes over to E. So this whole thing here is 360 minus X. And this piece is just X. Now if I subtract those two, which I'm showing you here, 360 minus X, minus the X, and I divide them by 2, then I get the outside angle, which the outside angle is 100 from that little arrow there. If I multiply, the opposite of dividing by 2 is multiplying by 2. That gives me 100. And again, I have negative x, take away x. Here it is, negative x, take away x. That becomes negative 2x. So I have 360 minus 2x equals 200. I'm going to switch these two. So this one is going to go to the right side, turn positive. And this one's going to go to the left side and turn negative. 360 minus 200 is equal to 160, and I still have 2x on the other side. If I divide by 2, I get x equals 80. But they didn't want that. They wanted me to give them the measurement of the arc DE, not x. So, but x happens to be the arc DE, so the arc DE is also 80. This concludes page 3 of your review. Number 1. They want me to find the measurement of arc MJ, and MJ is this pink one here. Okay, they also want me to find the measurement of angle LJK, which is the green one here, LJK. And they also want me to find the orange angle, which is LNK, which starts here at L, goes to N, and goes to K. So those are my 3 things that I need to find. Now, they told me this angle is 32, which is an inscribed angle. So if I multiply that angle by 2, here it is, I get 64. So that means I have just found the measurement of arc MJ. So that's 64. Now to find the green angle, I find out that it's also an inscribed angle here. And I know the arc that intercepts it, which is 82. If I take the 82 and I divide it by 2, then I'm going to get 41. So that's how I found the second angle. Now, the orange angle is a little tricky because it looks like a central angle, but there's no dot on this picture that shows me something's a diameter. I don't see any of that. So I'm going to assume that it's not a central angle because there's no dot. So what I have to do is I have to add the arcs that are across from it, which is the 82 and the 64. And I'm going to divide that by 2. And I'm going to get my orange angle. So the orange angle is actually 73. On number 4, I have both of these pink ones are radiuses. Now, this one's actually not in your picture, but we're going to assume that's they actually made a mistake on this, and they should have told you that this point here is a center. See, so that was a mistake on their part. Now, if that's a center, then that means I'm going from the center to the circle. That's a radius. And from the center to the circle, I could just draw another line. That's another radius. And since they told me it's 10 centimeters, so is this one. So now I have, and they told me this is a right angle, so that means this one on this side is also a right angle. So that means I can take out this triangle here, and I know all the measurements. So I know this is 6, I know that's a right angle, I know this is 10 because it's a radius, and the only thing I don't know is the A. So I'm going to use Pythagorean Theorem. Across from the 90 is the 10, so it turns into 100 when I square it. And then I have A squared and 6 squared, which is 36. If I subtract the 36, I'm going to get 64, and I have A squared. If I take the square root on both sides, A is equal to 8. So my answer is 8. On number 5, I also have a right angle, but this time because I have a tangent line and a radius. So that gives me a right angle. That means I have a right triangle again. They told me this is 17, this is x, and that's 15. Across from a right angle is the 17. That one goes first, and then the other two could go in any order. So 289 equals 225 plus x squared. Subtract the 225. I end up with 64. If I square root both sides, I get x equals 8. So the answer is 8. Number 6. I'm going to start with 93 and z. If I add them together, those equal 180. That means z is equal to 87. So now I found that z is actually 87. Now for me to find, I cannot add x and y yet because now I'm going to have 2 letters and I only need 1. So I'm going to try and find one of them. So I'm going to use this orange angle here, which is x. And I'm going to use the arc that goes across from it, which is going to be the 58 plus the 106. So I'm going to take this arc and I'm going to divide it by 2 because this is an inscribed angle. So I'm going to take the arc, I'm going to divide it by 2, and I'm going to get 82 because 58 plus 106 divided by 2 gives me 82. So now I know x. That's going to make finding y easy because now y plus 82 should equal to 180 right here. And if I subtract, that means y is 92. So I found x, y, and z. Number 7. These two angles add up to be 180. So 2x minus 7 plus x plus 1 equals 180. I don't need the parentheses since there's nothing here to distribute. And here it's a positive, so it's not going to make any changes. So I don't need the parentheses anymore. I rewrote them. And I actually am combining like terms. So the 2x and the x can be added together, put together. And the negative 7 and the 1 can be put together. So I end up with 3x minus 6 equals 180. If I add the 6, I'm going to get 86. If I divide by 3, I get 62. So my answer is 62. On number 8, since this is a tangent and this is also a tangent, they're actually equal to each other. So I set them equal to each other and I solved and I ended up with x equals 3. Number 9. Since I have a triangle with a diameter, that means this triangle is a right triangle. That means this angle is a right angle. I'm going to pull that whole triangle out of my picture so it's easier to work with. I know this is x because I'm looking for it. I know this is 3 and I know this part is 4. The hypotenuse goes always first across from the 90, x squared. And the other two could go in any order. So 16 plus 9 because 4 times 4 is 16. 3 times 3 is 9. That's 25. If I square root both sides, I end up with x equals 5. And x was my mk. So mk is 5. The answer is 5 for the diameter. Mk is the diameter because it has a center. This takes care of page 4 for you. On number 10, All of those problems here that are coming up are pattern problems because we have a right triangle and I have either a 45, 45, 90 or a 30, 60, 90. So on number 10, we have a 45, 45, 90. So if we remember, the pattern for these are 1, 1, 2. The last one gets the square root and the 2's get circled. The 2 gets put in the hypotenuse. So the square root of 2 gets put in the hypotenuse across from my 90. And these become A's. So that's an A and an A. Now, when I compare these two triangles, I'm going to see where I have a number. So if I'm looking at this red triangle, the only place I have a number is here or here. I actually have numbers on both. So I'm just going to take one. So as you can see, I'm comparing the two triangles. That means A is equal to 7. So I found my A. Now they're asking me to find AC. So AC is this one, which matches with this one. So my pattern says that my AC should be equal to A square root of 2. So AC equals A square root of 2. But I found A. A is 7. So in this place, I'm going to put a 7, which that would be my answer. 7 square root of 2. There's my answer. On number 11, I'm going to do the same thing, except that the pattern changes because that's a 60 and that's a 90. So that must be a 30. So I'm going to set up my pattern. And my pattern for a 30, 60, 90 is a 1, 2, 3. Last one gets the radical. The 2 gets circled because it goes in the hypotenuse. So across from the 90 is the hypotenuse. There goes the 2. The radical 3 always follows the square root of the 30 degree. So the 30 degree angle is here. That means right next to it, over here on my pattern, should be my square root of 3. That leaves me with the number 1, which is just A. And then remember, I put A's on all my numbers. Now, I'm going to take a look at my two triangles. And I'm going to see where they gave me a number on the outside, of course, on the sides of my triangle. Now, this is not a number because it's a variable, it's an X. This one isn't either because it's a Y. So the only place they gave me a number is 15. Now that matches with this spot on my pattern. So I'm going to set those two equal to each other. See, like this. And I'm going to divide both sides by the square root of 3. So it's going to be 15 divided by the square root of 3. I can't leave the square root of 3 on the bottom. So I'm going to bring it to the top like this. And then I'm going to take out the 3 from the inside and bring it out without a radical. These two will actually cancel. So 15 divided by 3 is now 5. But I still have my radical 3. So this gives me A. A is equal to 5 square root of 3. Now I need to find X and Y. So X is in this spot, which on my pattern says that I need to take A and multiply by 2. So X is equal to A times 2. And I know A. A is 5 square root of 3. So 5 square root of 3 times 2. Now the 2 is on the outside, so is the 5. The radical 3 is on the inside. That means I can only multiply the 2 times the 5, which turns into 10. And I still have my square root of 3. So X is equal to 10 square root of 3. For my Y, in this Y spot, that one's on the pattern, it's an A, so that means Y equals A. And A was 5 square root of 3, so that means that Y is equal to 5 square root of 3. And now I solve for X and Y. We get to practice this again. So this time we have a 30, 60, 90. So that's a 1, 2, 3. So we're going to have 2A in the hypotenuse. The radical 3 goes wherever the 30 is, which is here. So there's the radical 3 with an A. And that means A goes at the bottom. Now I have my pattern. 1, 2, 3. Now I'm going to look at my red triangle, which they gave me, and I'm going to see where they gave me a number on the outside. So the only place I'm seeing a number is here. And that matches with this side on my triangle, my pattern. So I'm going to set those two equal to each other. And if you notice that if I divide both sides by the square root of 3, then they end up canceling. And that means a is equal to 7. So for y, in this y spot, it says that y is equal to 2a. So y is equal to 2a, but a is 7. So 2 times 7 is 14. That means y is 14. For the x is down at the bottom. It matches with this a. So that means x is equal to a, which means right here, x is equal to a, which means that x is equal to 7. So I found my y and I found my x. I have them up here also as an answer. Number 13. This is a 45, 45, 90, which means it's going to be a 1, 1, 2. So this is a 1, this is a 1, and this is a 1 square root of 2. Remember, your square roots of 2's or your 2's always belong across from the 90-degree angle. So I find out from my triangle that I only have a number at 16 that matches with this spot on my pattern. So I'm going to set those equal to each other. I'm going to divide both sides by square root of 2. So 16 divided by square root of 2. I need to take my square root of 2 and move it to the top and take the 2 out. That means these two will cancel. 16 divided by 2 is 8. So that means my a is equal to 8 square root of 2. And that means I need to find x here. But x is equal to a. And I already found a. So that means x is equal to a. And a is 8 square root of 2. So that would be my answer, 8 square root of 2. Number 14. This is a 30, 60, 90, which means this is a 1, 2, 3. So that means I'm setting up the 2a, which is going to go across from the 90, 2a. The radical 3 always goes wherever the 30 is, which is on this side. So see, that's where I find it, square root of 3 with an a. And that leaves me with a. So the only place they gave me a number on my triangle is at 8. And that's in the hypotenuse in my pattern. So I'm going to set those two equal to each other. So 2a equals 8. That means a equals 4. So that means if I'm finding x, x is supposed to be equal to a. Which means that if x is equal to a and a is 4, x is equal to 4. Now y. Y and a square root of 3 are in the same spot. So that means y is equal to a square root of 3. But I know a. A is 4. So I'm going to put 4 in the spot of a. And that means y is equal to 4 square root of 3. And I'm done with that problem. Number 15. I have a new triangle. And they only marked these two equal. But because that's a 90, okay, the whole triangle is 180. And if they already used up 90, then that means these two have to be 90 together. But since they are equal, they're each 45. So that means I have a 45, 45, 90, which has a pattern of 1, 1, and square root of 2 in the hypotenuse with an a all the way around. Now I only got a number here on the 2. This is a variable, and that's a 2. Now that matches with the hypotenuse. If I set them equal to each other, I'm going to divide by square root of 2. That means the square root of 2 is going to be in the bottom, which means I have to move it to the top and take the 2 out. The 2's cancel. That means a is equal to square root of 2. Since I'm looking for x, x is equal to a, but I already found a. A is equal to the square root of 2. That means x is equal to the square root of 2, and that would be my answer. This concludes page 5 and your entire review. Good luck on your test tomorrow.